And hello bosses, I am very happy to see you again for a new video. So today we're going to talk about virtualized environment for Python management, because you may have noticed that when you install Python scripts or Python tools that you can download from GitHub, or when you develop your own tools, sometimes these tools or what you develop requires specific packages or specific versions of Python, and unfortunately it can conflict with other tools, other versions, etc. So for that there are solutions. You may know PNV, you may know virtual ANV, this kind of thing, which are free tools which are already a little old and not necessarily super practical to use. You may be familiar with proprietary tools like MiniConda or MiniConda. The goal of this video is mainly to discuss MiniConda, how to use it, how to manage it, in order to have virtualized environments for your Python installations, whether they are your own tools that you develop or tools that you download and install. As a reminder, e.g. virtual env, it lets you create isolated Python envs for different projects. Advantage of virtual env is it's simple, lightweight, great for isolating Python dependencies, but unfortunately limited to Python packages, doesn't handle system dependencies. We may still encounter minor issues with this tool. It is also an older tool, developed during the time of Python 2's release. Well, then we also have PNV, which you may know, which only allows you to manage Python versions. It enables you to switch between Python versions, but solely manages that, not dependencies, packages, and so on. In proprietary tools, we have MiniConda, which I have never told you about, I think, because MiniConda is a proprietary tool that is a complete distribution, especially for data scientists, people who do complex things with math, data analysis, etc. Many libraries in it for all things related to data science. But it's a tool that is very heavy, too complex for our needs. So there you have it, that's why I don't dwell on it. On the other hand, at the best of both worlds level, which is also a proprietary tool but is a lightweight version of MiniConda with flexible environment and package management, so we have the best of both worlds. It's a lightweight, modular tool suitable for customizing the dev environment or deployment, perfect for your needs. It has fewer pre-installed packages than MiniConda, there are more configurations due to the command line, etc. However, in my opinion, it is more efficient than virtual env or PyEnv for our tasks. That's what we'll start with. I'll demystify this a bit, explain how it works. But before that, I want to thank the Patreons for their support. Thanks to them, I can make these great videos. Thank you for supporting me, my website korben.info, my videos. If you want to join us, go to patreon.com/korben for early access to all these videos and articles, and most importantly to support me. It's not insignificant. I suggest that we attack directly into the tough part, so for that I share my screen with you, and I'm currently on the conda.io website. Visiting conda.io directly, I fall and get redirected to docs.conda.io, the site with all the documentation and different projects. It presents comprehensive documentation and various projects. So we have Conda, which is MiniConda, and we have the MiniConda project, which interests us, being lighter and simpler to use. So MiniConda is a tool that is available on Windows, Mac, Linux, which will allow us to create virtualized environments. So, as a reminder, it's a virtualized environment, isolated from each other. This enables separate Python installations with different packages for different projects you work on. It avoids conflicts between packages and so on, because sometimes we install tools that use specific versions of packages, and therefore it will overwrite other available versions of packages, and other tools that may use other versions will no longer work, and so on. So, using Python on your system can quickly create a mess, and tools like MiniConda help to segment things properly, and so on. To have well-separated environments, to avoid all these conflicts, to be able to have different versions of packages, and also to ensure that when you set up a project, it is reproducible from one machine to another because you have the same environment with the same Python interpreter in the same version. And the package dependencies, that are the packages that depend on your project, are exactly the same. And all this does not affect the system and the Python installation of your system. So, to install it, you have different possibilities. As it is a tool, I was saying Windows, Mac OS or Linux. You have here the installers, so you can download them directly. It is either tscript shell to launch or package points or exe points for Windows here. So we also have command lines. So if you want to launch a small terminal, you have here the small command lines to copy. So it often consists of a curl that will retrieve the binary or script, and that will launch it to deploy MiniConda on your system. I launched the GT Charlotte package, so I'm going to install it here. Nothing very complicated. On Classic, we see Python version 3.11.5. Installer list is for latest Python version 3.11.5. We are on the Classic. We'll see how we change after the version 2, but there you will have something to have fun with. Once set up, there's nothing left but to open a terminal, so I'll zoom in on it a bit. I'll go to my download directory, create a work folder, go in there and familiarize ourselves with Conda. First, we'll check the Conda version, so we'll launch it and check if it launches. We'll use the command clean the terminal, launch Conda version. Check if it's installed, if it's what we have, etc. If it's fine, display Conda version. Very good. Now I'll create a new env, so I'll just enter the command, I'll try to zoom in a bit more. And there, I'm going to give it a name to my environment so I can call it whatever I want. In fact, I can call it my project there without any originality, but you see the spirit, so it will start creating what is needed. And tell me here, I'm going to install all these little packages in your environment. Here's what's planned. It will be Python 3.10 because it's compatible with your system, etc. We have RM. Everything is okay here. I do yes, why. So it will download everything needed for my virtualized environment. Here, currently not in the environment, just created it, we'll need to activate it. Now receiving direct command, will execute Conda activate my project. Here, now I'm in my environment. Conda with the correct version of Python, packages, and now I'll be able to evolve, actually do my installs, do all my development in this environment. We see it because I have, in parentheses, my project indicated here, and I see that, well, I'm in this context. Made Python ver, I see well that I'm in 3.10.13, whereas if I launch another term without being in my env and I do Python ver, I'm in 3.12.1. So you see it's not that it's my classic sys, here's my ver of Python on my whole sys, and this is the ver I currently have in my project. We'll see later how to change that. But here it is now. If you want to exit your env, that is to say disable it and return to your well out of the Conda env, you can type the cmd conda deactivate, it'll just disable, so you'll see I find my classic shell and I no longer have my pro in parentheses, so I'm no longer in that env. Well, I am returning by executing Conda activate my project, and then I can make progress in this project. That is to say that if you open your code editor and launch a terminal, you can also utilize it in that way, so you are able to execute Conda activate my project. Here I'll create a code and ask my editor. So this is a tool I've already talked about in a video called Cursor, but I ask my editor to make a hello world using the NumPy and Pandas libraries. We don't care how you say it, but for now. So there you go, it generated a hello world for me. Hello world, it creates an array with 1, 2, 3, 4, 5, displays the array in UTC with NumPy, and puts some data. France, Spain, Germany, with numbers related to the population of each of these data. It creates a data frame, a table of data, and displays it with Panda. Here it's just a small hello world, a quick thing. If you want to learn more about Cursor, I invite you to watch my video on the subject. Cursor is an editor. It is a Visual Studio Code if you want, enhanced with AI, including ChatGPT, the AI from OpenAI, and it allows you to generate code, correct code much faster and easier, especially when you are a beginner, directly within it. It's a project I like, it saves time. Here it is, here I am, I have my code managed. What you need to know is that NumPy and Pandas are not installed. They are not libraries I have installed. Me in Visual Studio Code, here at the bottom you can choose the version of Python to run. So we click here at the bottom, I show you here, so there, and there it will display the list of different versions of Python. There is a lot of mess in quotes that I installed. We can see my project, the Python 3.10.13 version of my project, which is there, that I will be able to choose. So actually, if I run my code, just reading here, it will run the code using the Python version. Specific to my environment, and obviously you see that it doesn't work because I haven't installed NumPy. So now we will see how to install the libraries, dependencies and libraries directly with MiniConda. You have two options. Use pip to install pandas or utilize Conda, which already includes pip and does not require a separate installation process. But here he'll go get pandas and he'll install it. He also installs numpy in the process. You can use pip as usual, it won't change anything. Alternatively, you can use the command conda install and type numpy or another package. It will indicate if it's already installed, but it will proceed with the installation. The packages, including dependencies that will be downloaded, are listed. Here's what will be installed. He's clear about what's in place. That's cool. I install. There you go. So normally I have everything I need to run my code. I have pandas and numpy, so I will restart my code and it displays the result of my code. Here I am in a virtualized environment with dependencies installed. It works perfectly and there are no issues whatsoever. If I leave this project, I do conda deactivate and then launch it with my system's Python 3.12. Unsure if I have installed numpy and pandas, relaunch it, error again, tells me not installed because I'm no longer in the virtualized environment. If I launch with 3.18, even if I'm not actually in the virtualized environment here at the level of my terminal, calling the correct version of Python from my virtualized environment, which is in my home directory, there is MiniConda 3 that was created when I installed the folder, and there we have the env, the environments. Now I have my project created, and inside I have my Python version with my dependencies, libraries, etc. So everything is integrated in one place. So he tosses it and there are no concerns. I'm returning in. Here I am once more in my project as it should be. Now I am on 3.10. Let's say I want a version of Python 3.8. Come on, let's be wild. How will I do it? I'll enlarge so you can see what I'm typing as a command line. We'll do a little clear. Here I'm just going to type conda install and then I'm going to say here I want this version of Python, so I do Python equal, for example, 3.8 or 3.9. Let's install 3.9, so there it tells me here's what's going to happen. Actually, you're going to switch to 3.9 knowing that before I was on 3.10, you're going to switch to 3.9, or I could have said 3.12. And it looks at the packages it needs and it tells me I'm going to downgrade, so I'm going to lower the version of all these packages there, all these tools there. In fact, it adjusts the environment to the Python version I'll set up. I'll do it, he'll get everything, install all he needs. Now when I do Python version, I will have Python 3.9.18 as my version. And if I run my script, normally since the packages haven't moved, well apparently it has moved, I need to reinstall the pandas packages and probably numpy. Now I'll do conda, install, conda, there you go, it installs everything. I could have merged them, conda, install pandas and numpy. I'll also install numpy. Usually he had to do, there you go, he says it was already installed, well done. I start it, there my project, finally my code runs. And I am indeed in version 3.9, here, Python version 3.9. Now if I desire to test this same script in two distinct virtual environments, it is a straightforward process. I'll show you how I do it. I do conda deactivate, I exit my current environment and I will do conda create. I indicate the name of my project, which I will label as my project 3.12 for identification. There I'll specify the Python version I want to install. I'll say Python equals 3.12 to have version 3.12. We'll check if it's supported. It offers to install. I say yes. Then I can activate my project in Python conda, activate my project 3.12, and if I do Python version, I'll have version 3.12. This allows me, for example, by changing, in fact, about the env, I can run the same code or not. In fact, I can say here, I want you to launch such and such version. So when I go into the versions of Python in VS, I refresh here and I see that I have my project 3.12, which is there, so I can run my code directly from VS in 3.12, so it will complain because there is no external MPI. So I will do little conda install, and as numpy, it will install everything, which is quite fast finally. And I just have to restart my code and it will run fine in version 3.12 of Python. So here we are on something lambda. I did a hello world, etc. But there are some projects that only run with specific versions of Python. So there you go. You can easily juggle between versions. So there you go there. It is well launched. And then, well, if I do conda activate my project, I go back to a version of Python, which is 3.9. We will check, but here I am again in 3.9 and I can relaunch it directly in Visual Studio or with the command. The right command, see the command, it is there, it's user manu miniconda env my project, there it's my project 312 just above, and then I have the Python binary installed. And it is the same thing with the libraries. There, as I installed, I did a conda installation of Python equal to 3.12, for example. I could do conda install pandas. I don't know the version numbers of pandas, but I can put, here we are at 2.114. I can inform him I want v2.1.3, for example. She may exist. Apparently it's not available in the packages, but on the conda servers. To do that, go to anaconda.org. Here, upon arrival, search for the desired version on the site. This is what we can do to help. So type e.g. panda 2.1.3, your version. We'll type pandas, that's it. He suggests, there, 2.14, 1.5.2, 1.4.3. So, come on, let's not hesitate to do everything. And there you go. Let's say I want to install this one, version 2.1.1, because I have specific reasons to install this one. I can get the order like this and switch and do conda install fastchan 2.2.1 panda, because it is the fastchan repository that has this specific version of panda, etc. On Anaconda we find it like this. It's not specific or visible on the website, but we can search for different versions like this. It is actually a repository, so you have a bit of the same spirit, for example, as those who know Docker. You have everyone can maintain their versions, etc. Here we have CondaForge, the official version in quotation marks, and other versions, each with their own little version. Find the version that interests you. If you want to go through official repos, you can also use pp command, do pip. To install pandas version 1.2.3, use pp, also known as pipe, which provides access to repositories containing various package versions. This allows you to retrieve the desired package versions according to your needs. So there you go, you don't have to go through the pandas repositories. You can also use pip, which is the official Python tool, and install the versions you want that way. Although no need to worry overall, it's better to have the latest versions with the associated Python version. But you never know, sometimes there are projects that need specific versions, and in that case we can install them too. They'll be saved for the env. There you go. Well, I won't give more detail. I think it was clear enough as a tutorial. It's simple. It was to demystify virtual environments in Python, because whether it's people who develop, sometimes I develop 2-3 things, but what happens to me much more often is testing tools. And occasionally, these tools may necessitate libraries, versions, or specific versions of Python that can be somewhat complex. Let's say it is not worth breaking your entire system in order to test this tool, so for that purpose, the correct solution is indeed virtualized environments. Clearly, this implies that if you wish to run your script within its virtualized environment, you will need to activate the source, so you will have to execute a conda activate your project command, or directly call Python by specifying its path in the command line. We can explore a bit of that. In MiniConda installation I have this, and inside we have envs, environments with projects, and in each project we find binaries, everything that goes well, lots of metadata, installed libs, etc, everything that is shared. So we can call, that's what I was saying, directly call the version of Python that is here, which will be, here we see it, it's just here when I called it. It was this link and followed by my script. So you can still call it in other scripts or in your automation tools. You can call this path, this version of Python, and it will execute it directly in the appropriate environment. Here, I hope you enjoyed it, that it interested you, that it will be easier for you to understand how it works. It's not hard. That's why I like Conda, even if, indeed, it's not an open source tool, it's not free, etc. I find it less of a hassle to use than virtualenv, copyenv, jongle with both, actually. There, all is integrated, all is easy, it'll save you time, that's it. Thanks again for following me. Don't forget to join us on Patreon if you haven't, Patreon.com/Korben. Thanks dear support, see you soon, bye.